This is the question. I'm going to assess your understanding of the WhiteKernel in Sklearn's Gaussian process regression. Get ready. Let's see how well you know this topic. This statement describes a core feature of the WhiteKernel. It adds the same amount of variance to each data point individually. Think of it like adding a bit of consistent, independent noise to each measurement. It's true. Because WhiteKernel adds noise to each data point, it is really helpful for accounting for the uncertainty or random fluctuations present in the data. It's true. The WhiteKernel has a setting, a hyperparameter, often called "noise_level", that lets you control how much noise gets added. You can adjust it to fit your data better. This statement is true. This is false. The WhiteKernel adds independent noise. The noise added to one data point doesn't affect the noise added to another. There's no connection created between the data points. These are the options that accurately reflect how WhiteKernel works. It adds independent noise, models noise in the data, and has a control for noise level. This is the title of a multiple-choice question about the WhiteKernel in Sklearn's Gaussian process regression. I'll be explaining the choices. This is the core question. We need to determine which statements correctly describe how WhiteKernel functions within Gaussian process regression in Sklearn. This statement is true. The WhiteKernel adds a constant value to the diagonal elements of the kernel matrix. Think of it like adding a consistent amount of noise to each data point independently. This statement is also true. Because it adds noise to the diagonal of the kernel matrix, WhiteKernel helps to account for inherent uncertainty or random variations present in the data. This is true. The WhiteKernel usually has a parameter, often called "noise_level", that lets you adjust the amount of noise added. It's like a volume knob for the noise. This is false. The added noise is completely independent for each data point. WhiteKernel does not create any relationships between the data points. It only adds its own noise to each data point. I'm diving deep into Sklearn's WhiteKernel, a crucial component in Gaussian process regression. It's all about understanding how it works and what it does. Get ready to become an expert. We'll tackle a multiple-choice question to test your understanding of the WhiteKernel. This will help solidify your knowledge. Let's see how you do. The kernel matrix is the heart of Gaussian process regression. It's a representation of the relationships between data points. Think of it as a map showing how each point is related to every other point. The diagonal of the kernel matrix represents the variance of each data point. It's like a special column that focuses on the individual data points. The WhiteKernel adds noise to the diagonal of the kernel matrix, representing uncertainty associated with each data point. It's like adding a little bit of randomness to each data point's variance. The WhiteKernel has a hyperparameter, often called "noise_level", that lets you control how much noise you add. You get to fine-tune how much randomness you introduce. I'm diving into the core concept, the WhiteKernel in Sklearn's Gaussian process regression. Get ready to learn something cool. We'll explore what it does and why it's useful. This is the main question. We need to evaluate each statement about the WhiteKernel to determine whether it's true or false. It's a multiple-choice question, so select all that applies. This statement says the WhiteKernel adds a constant value to the diagonal entries of the kernel matrix, representing added noise variance to each data point. I'll explain if this is true or false in the next sections. This statement claims the WhiteKernel helps us include noise into our model. I'll check if this is correct and explain my reasoning. Here, we're examining whether the WhiteKernel creates relationships between data points. I'll figure out if it does or doesn't. This statement suggests the WhiteKernel has a setting, a hyperparameter, that adjusts the amount of added noise. Let's see if that's true. And the final answer will be revealed based on my explanation of the previous points. I see. This is a multiple-choice question testing your understanding of the WhiteKernel in Sklearn's Gaussian process regression. Let's tackle each option one by one. This statement is true. The WhiteKernel's core function is to add a constant value to the diagonal elements of the kernel matrix. Think of the kernel matrix as representing relationships between data points. The diagonal represents self-relationships. Adding a constant variance here increases the noise associated with each data point individually. Absolutely true. By adding independent noise to each data point, the WhiteKernel directly models the inherent uncertainty or randomness present in real-world data. This is false. The added noise is independent for each data point. The WhiteKernel doesn't change the relationships between different data points, only the uncertainty associated with each individual point. This is true. The WhiteKernel typically has a parameter, often called _noise_level, that lets you adjust how much noise is added. A higher value means more noise, a lower value means less. This is simply the title of the quiz question. This problem focuses on understanding how the WhiteKernel function works within scikit-learn's Gaussian process regression. It's all about knowing the facts and how WhiteKernel impacts the process. We'll tackle a multiple-choice question, testing your understanding of WhiteKernel's behavior. Get ready to show off your knowledge. I'll present 4 statements about WhiteKernel. Your job is to identify which are correct. Let's see how well you grasp the concept. This statement says WhiteKernel adds a fixed amount of variance to the main diagonal of the kernel matrix. Think of the main diagonal as representing the individual data points. Adding variance to it means adding noise to each data point individually. This proposes that WhiteKernel helps us represent the uncertainty or random error present in our data. It's like acknowledging that real-world data isn't perfect. This statement claims that WhiteKernel makes data points dependent on each other. We need to carefully examine if this is true or false. This suggests there's a setting in WhiteKernel that lets us adjust the amount of noise it adds. Think of it as a knob to control the noise level. I'd like to clarify what ID means: independent and identically distributed. This signifies the noise added by WhiteKernel to each data point is random, and the same type of random noise is added to each point without influencing others. This is an important characteristic of WhiteKernel. This is the overall question about the WhiteKernel in scikit-learn's Gaussian process regression. I'm going to explain what a WhiteKernel does and help you choose the correct answers from the multiple choice options that follow. This line introduces the topic. We're dealing with a multiple choice question about the WhiteKernel, a component of Gaussian process regression within the scikit-learn machine learning library. Let's dive in. This is the core question. I need to assess several statements to determine which accurately describe the behavior and purpose of the WhiteKernel within the context of Gaussian processes. Statement A claims that the WhiteKernel adds a fixed amount of variance to the diagonal entries of the kernel matrix. The kernel matrix represents the relationships between data points in a Gaussian process. This is crucial because it essentially adds noise to each individual data point. Statement B suggests that the WhiteKernel is helpful in accounting for inherent uncertainties or noise within the data. This is directly related to the fact that it adds variance. Think of it like this: real-world data is never perfect. The WhiteKernel helps capture that imperfection. Statement C claims that the WhiteKernel introduces correlation among data points. We'll see that this is false because it only modifies the diagonal. Statement D states that the WhiteKernel's behavior, specifically, the amount of noise added, is controlled by a setting, or hyperparameter. This is very common in machine learning. You often tune these settings to optimize the model.